This lesson is for section 5.2. We're going to be graphing quadratic functions. Today we're going to be graphing quadratic functions using a table, and then graphing them by finding the vertex, and then using something called symmetry to find symmetric points. And then we're going to be given the vertex and a point on the graph. We're going to find additional points using that concept of symmetry again. So let's get to the first method. Method 1 is graphing from a table, which is something you've already done in chapters 1 and 2 quite a bit. Now remember, this is a parabola, and every quadratic should be U-shaped, so we should get a shape that either looks like one of these. Now, make sure that you get a U-shape. If you get something that looks like that, that's not quite a good graph. You need to extend your points so that you can find additional points on that graph. So you always want to get a good U-shape when you're graphing these. So you want to see the X-intercepts, you want to see the Y-intercept, and you want to see the vertex. So it's really hard to mess this up unless you don't follow something called order of operations correctly, which some of you do have trouble with. So make sure that you're really making a conscious effort to do the order of operations correctly here. Alright, so when I look at this, I do know that this is going to open downward because there's a negative out in front of this. I also know it's going to be shifted up too. So this is a lot of review from a long time ago, so if you don't remember that, that's okay. We're going to go through that again. So I'm going to pick my standard -2 to 2 here just to see if I get a decent graph. When I plug in -2 squared, I get a +4, multiply that by -2 plus 2, and I'll get -6. And then I'm going to go ahead and fill out this table. I'd like you guys to pause and do the same. Alright, now after I plotted those points here, I'm going to see a U-shape. And it's actually going to be a pretty decent U-shape here. So I have the point at, I am totally not graphing that right, -2, -6, 2, -6, 0, 2, -1, 0, and 1, 0. So I do get that U-shape. And you can see the point of reflection here. Once we get to 0, 2, notice how these values start bouncing back off from there. Okay, those y values start bouncing once you get to this coordinate here, 0, 2. So that would be your vertex here. And you can clearly see that here when we graph that as well. Our second method is going to be using the vertex. So we are going to algebraically calculate where that vertex is, and then use symmetry to find additional points on the graph. So again, the idea of symmetry just means that you have on one side of something the exact same, like think of it as a mirror, basically. So we already know a few things about a quadratic that's written in standard form here. We know that a quadratic opens up if that a value is positive, and we know it opens down if that a value, this number out in front, is negative. So that determines whether it opens up or down. It will also decide whether it's a stretch or shrink, but we'll talk about that in just a second. Now the vertex, this is something new, so you're definitely going to want to write this down and pay close attention to this. When you want to find the vertex, the coordinate of the vertex is given by taking the opposite of b and dividing it by 2a. That's the x value for that coordinate for the vertex. And then to find the y value, you have to plug -b over 2a into your function, back into your function to find the y value. So in notation, we'd see opposite of b over 2a, comma, f of opposite of b over 2a. So we'll do that a couple times just so you get the hang of it, but this is a new formula for you that you will memorize, opposite of b over 2a, and then this part isn't so much needed to be memorized because you're just going to plug that value right back into your function. Alright, now the axis of symmetry. If we think about a quadratic, you always have a vertex on a quadratic, and through that vertex is always your axis of symmetry. It's where it divides the the parabola into two symmetric parts. So this axis is given by x equals, because it's a vertical line, and it will always be the x coordinate of your vertex. So we just talked about what that x coordinate will be. It's opposite of b over 2a. So the axis of symmetry is always the equation of the line, x equals the opposite of b over 2a. Okay, this is, whoops, didn't mean to put it in a comma. This is the equation, so make sure you always have x equals, and we'll go through a couple problems just so you get the hang of it. Alright, now, using this method, I'm going to start with this quadratic here, and I'm going to answer these questions here. This will be basically in every single homework question. I want you to always answer these questions here. This quadratic is going to open up because this is a +1 out in front. Now going back to when we talked about, absolute value functions, anything, we know that if this value out in front is greater than 1, so its absolute value, the absolute value of A is greater than 1, then it's going to be a stretch. If its absolute value is less than 1, then it'll be a shrink. In this case, the absolute value here is just 1, so if the absolute value equals 1, then it doesn't open, or it doesn't stretch or shrink, so it's neither. Okay, it's the same. Now the vertex of this, we're going to take the opposite of B over 2A. And then for the y value, we have to plug in the opposite of B over 2A. So I take the opposite of B, which is 4, and divide that by 2 times 1, and that gives me the x-coordinate. So the x-coordinate here is 2, and now I'm going to plug in 2 back in to the function. So I'm finding now f of 2, and we've practiced this. We've practiced how to plug 2 into here and find f of 2. That's just plug in 2 into each of these x-coordinates here, or I'm sorry, x values here, so that we have 2 squared minus 4 times 2 minus 3. So we evaluate that, and we end up with f of 2 equaling 4 minus 8 minus 3, so we get negative 7, which means that the y value is negative 7, so we have the coordinate for my vertex of 2, negative 7. Okay, this is the vertex. Now that also means, because we know that if it's a parabola and it's opening up here, that the vertex has to the axis of symmetry, has to pass through that vertex. So that means the axis of symmetry, which is always the equation x equals, because it's a vertical line, should be x equals 2. It's going to be the x-coordinate of your vertex. Okay, so let's start with graphing what we already have. We know that this vertex is at 2, negative 7, and we also know that it opens up. We are also going to have an axis of symmetry through that parabola at x equals 2. Now I do want you to always show the vertex and the axis of symmetry, and you're going to label those coordinates very clearly. You will also always find 5 points for your parabola. Okay, that's the magic number here. We always want 5 points. Now you might ask yourself, well, how am I supposed to find these points? Well, you could plug that back into the table and pick some values, like plug in 3 next, plug in 1, that kind of thing. But there's a little bit quicker way to do this, and that's by looking again back at your function and looking at it to see the y-intercept. Whoops. So the y-intercept here is at negative 3, because if I plug in 0 for x, that term goes away, that term goes away, and I'm left with negative 3. So I already know the y-intercept here is 0, negative 3. So I'm going to plot that point, and then I'm going to use the idea of symmetry to find an additional point. Well, if I look at this graph, that y-intercept is 2 spots away from the axis of symmetry. So what I'm going to do is start at that axis of symmetry and count 2 spots to the right and place an additional point there. So now I have 3 points for my parabola. Okay, and now I want to find a couple more. You're always going to have to include the y-intercept and the x-intercept, so that's pretty much how you're going to find your 5 points. To find the x-intercepts, it's a little bit trickier, but basically you're going to do the same thing we've been doing before. If you want to find an x-intercept, you want to let y equal 0. You already know that the y is supposed to equal 0. So I'm going to start with my original function. F of x is equal to x squared minus 4x minus 3. And I'm going to set this y value, remember f of x is the same as y, I'm going to set that equal to 0. So I have 0 equals x squared minus 4x minus 3. Now, when I look at this quadratic, I want to try to factor this because it's going to be the fastest way to solve for this. In this case, it's not factorable, so I would use the quadratic formula. So this is something that you should be able to do, and if you have that skill, it will be very easy for you. So I'm going to do that real quick. Okay, so after I did the quadratic formula here, I end up with 2 solutions. X is going to equal 2 plus or minus root 7. This is how I simplify this. Now, you have to graph this coordinate. So what this is saying is you have an x-intercept at 2 plus root 7, comma 0, and you have another x-intercept at 2 minus root 7, comma 0. So these are 2 distinct points. Okay? And we're going to graph those 2 intercepts. Now, what you're going to do is use the idea of approximation. We know that square root of 7 is smaller than the square root of 9, but it's also larger than the square root of 4. Okay, it's in between square root of 4 and square root of 9. Well, the square root of 2 or 4 is 2, the square root of 9 is 3, which means that the square root of 7 is somewhere in between 2 and 3. Okay? So what this coordinate is saying, it says start at 2 and then go an additional 2 to 3 units, between 2 and 3 units. So I would start on the x-axis at 2, okay, which is right where my vertex, my axis of symmetry is going through. And then I'm going to go about 2.5. It doesn't have to be, exact, but between 2 and 3 points, okay, away. So again, I'm just going 1, 2, not quite 3, but somewhere in between. And then I'm going to do the same exact thing to graph this other point, 2 minus root 7. So I'm going to start at 2, and then I'm going to go backwards by about between 2 and 3 boxes. So 1, 2, and about right there is where I land now. So here's how I find my 5 points. And now that I have those 5 points, I can just draw a smooth curve through those. Okay? So this is how you're going to graph when you're asked to find the vertex. Okay? And then additional points like the x and y intercepts. Alright, I'd like you to pause the video and try problem 3. It's going to be really similar to the last question we just worked on, and it'll give you practice with that whole idea of approximating the square roots. So please try this one. It'll prepare you for any video check that we have as well for tomorrow. Okay? So definitely try me, please. Alright, our third method is using x-intercepts and the vertex. So it's actually very similar to what we just worked on. But you will always be asked to solve and find the information that is following each problem here. So make sure you are very comfortable with each and every one of these terms, as well as how to find each and every one of these and the answers to each part. Alright, this parabola is going to open down because that value out in front is negative. It will not be a stretch or a shrink. It's going to be neither, because this value out in front, its absolute value, remember you're taking that number out in front. If its absolute value is less than 1, then it becomes a shrink. If it's greater than 1, then it becomes a stretch. But since this one, its absolute value is equal to 1, it is neither a stretch or a shrink. So let's work on finding the vertex. We're going to take the opposite of b over 2a. So the opposite of b here is going to be negative 2 over 2 times negative 1. Make sure your signs are always correct. It's very easy to mess up on this. So we end up with negative 2 over negative 2, which is positive 1. That's my x-coordinate. Now I'm going to find f of 1 to find my y value here. When I plug in 1, I get negative 1. So 1 squared with a negative out in front is negative 1. This is really the opposite of x squared. Okay? So we have negative 1 plus 2 plus 3, and that gives me 4. So my coordinate for my vertex is 1, 4. Okay, the axis of symmetry, remember it goes through the x-axis, or the x-coordinate, so it's going to be x equals 1. Don't just write 1 here. You will lose points and credit on your test or quiz if you just write the number 1. It's the equation of a line, which is why you need to write x equals 1. Alright, now for the y-intercept, that's the easy one. We're going to look here, and we have a y-intercept at 3. Okay, it's going to be your constant term, because if I plug in, remember for finding a y-intercept, all you're doing is letting x equal 0. So if I plug 0 into here, this term drops out, this term drops out. I'm always left with that constant term in that parabola. Okay, or in the quadratic, I should say. Okay, now for the x-intercept, this is where we let y equal 0. So if I plug in 0 equals negative x squared plus 2x plus 3, I now have a quadratic that looks just like your quadratic worksheet from days 1 and 2. So let's solve this. The fastest way I think to solve this is to factor out that negative, and from here I can factor this trinomial that's left over. I'm just looking for two numbers that will multiply to negative 3 and add up to negative 2. Those two numbers are negative 3 and 1, so I have the opposite of x minus 3 times x plus 1. And I have an x-intercept at 3 and negative 1. So now I have enough points to go ahead and graph. I'm going to start at 1, 4, my vertex. Remember, my axis of symmetry does go through that. So I have the point 1, 4 here. I don't think I labeled very well in the last one, but make sure you're always labeling. Okay, I have my axis of symmetry at x equals 1, and now I'm going to plot additional points. So I have the y-intercept at 0, 3. And I'm also going to use the axis of symmetry to find that other reflection point. There's a reflection point right here. Okay, one unit away from that axis of symmetry. I have the points 3, 0 and the point -1, 0. So make sure for the x-intercepts too, you're also listing them as coordinates. Okay, so we have 3, 0 and -1, 0. And you should always verify that your points actually make sense with the axis of symmetry, because notice how these are 2 spaces away also from that axis of sym. So there's my parabola. I have my 5 points. Make sure you do label those 3, 0, -1, 0, and 2, 3, and 0, 3. Okay? Alright, the last section here is going to be very, I think, abstract, and it really makes sure that you understand this whole idea of using symmetry. Okay? So the first question says, given that the vertex of a parabola is at 100, 300, and 88, 263 lies on the parabola, find an additional point lying on the parabola. Okay, it really helps, that's why I have this hint, to draw a sketch. Okay, once you have this concept of symmetry down, this should be a really basic problem. But first we have to get an idea of what this graph looks like. So we have a vertex at 100, 300. So it would definitely be somewhere up here in the first quadrant, 100, 300. I'm just kind of throwing out a point. Doesn't have to be, units don't have to be great here. Now the point 88, 263 lies on the graph of the parabola. And that point would be somewhere to the left and below it, right? It's to the left because this value is smaller than 100, and it's below it because 263 is less than 300. Which means if we're going to use the axis of symmetry idea, that another point on the graph would be somewhere over here. Okay? It's going to be in the horizontal direction, but right across from that point. So now we're going to use the idea of symmetry to calculate the exact coordinates. Now hopefully you're recognizing that this y value has to be the same for either point. So I already know that this new point, this xy here, has to have a y value that is equal to the y value over here, which was 88, 263. So the y value here is 263. It must be the same. And now for the x coordinate, I know that the distance between these 2 points has to be the same from this point to the axis of symmetry, and from this point to the axis of symmetry. So all I have left to do now is figure out how far away this point is on the left away from that axis of symmetry. Remember, your coordinate here was 100, 300. Okay? This is the x value, and this was our starting x value for the other point. These are 12 units away from each other. Okay, 12 units away. So now I want to go 12 units on top of that in the direction to the right, which means that the x value is now at 112. I'm simply adding 12 to 100. So my coordinate is 112, 263. Okay. I'm going to do problem 2 with you, and I'm going to ask that you try problem 3 for yourself. Okay, so problem 2 gives me a vertex at -20, 30. So -20, 30 is somewhere in this second quadrant over here, and this is the vertex. The point 15, 245 is in the first quadrant, all the way probably, I don't know, up there somewhere. Okay, so if we're going to use the idea of symmetry, we would draw that parabola, and we know that this point has to be on the other side over here with the exact same y value. So our new coordinate, if this was 15, 245, our new coordinate's y value is also 245. The only thing we have left to find is the x value. Okay. Now this coordinate for the vertex is at -20, 30. What we need to do is figure out how far away our point is away from that axis of symmetry. So we went from -20 all the way to 15. A lot of people want to say the answer is 5 here, but these are not 5 units away. They're actually 35 units away. To get from -20 all the way to 15, that's a total change of 35 units. So that means that from this coordinate here, we want to go 35 left, 35 points to the left. If I go 35 to the left, I'm taking -20 and subtracting 35 to get -55. So that x value is at -55. So I have the coordinate -55, 245. Okay? Alright, so all you have left to do now is problem number 3, and make sure you, if you didn't do the second graphing one on your own, that you do that and then check with the key. That's the end of the lesson. I'll see you guys in class tomorrow.